Okay, so for today's AP problem number 11, part A asks you to consider the carbon dioxide molecule CO2 and carbonate ion CO3 2-. Draw the Lewis structure for each species. So first we're going to find the valence electrons for CO2. So you're going to know there's 2 oxygens, which is 6 times 2, plus 4, which is 16 valence electrons. So you're going to put double bonds on the C and the O on this side and this side. So you get 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. So for CO3 2-, you're going to do the same thing in finding the valence electrons. So 6 times 3 is 18, plus 4 is 19, 20, 21, 22, plus the 2-, so that's going to be 24 valence electrons. So once you start drawing this, I added a double bond so it could complete the 24 valence electrons, but I realized that this structure has resonance, so I drew the 3 different resonance structures with just the double bond shifting over one. So part I says, account for the fact that the carbon-oxygen bond length in CO3 2- is greater than the carbon-oxygen bond length in CO2. So in CO2, the carbon-oxygen interactions are double bonds, which indicates a shorter bond length would occur compared to the carbon-oxygen bond length in the resonance forms of CO3 2-, which would be longer. Just because the shorter the bonds, the shorter the bond length. They're directly proportional, and the longer the bond length. Or the weaker the bond strength, the longer the bond length. Okay. For part B, consider the molecules CF4 and SF4. Draw the complete Lewis dot structure for each molecule. So for CF4, I found the valence electrons, which would be 32 valence electrons, and I knew that it would just be single bonds with full octets, which would be A, 16, 24, 32. And then for SF4, I knew that it would be 34 valence electrons, so I knew that I would need single bonds for all of them, but the only difference between CF4 and SF4 would be that this one would have one lone pair right here. So part I. In terms of molecular geometry, account for the fact that CF4 molecule is nonpolar, whereas SF4 molecule is polar. So the CF4 has a tetrahedral geometry, so the dipoles cancel each other out, which makes it a nonpolar molecule. While in SF4, there are 5 domains of electrons that surround the central atom S, which puts it in a trigonal bipyramidal geometry with a lone pair of electrons. In this configuration, the dipoles don't cancel, so the molecule is polar.